Alright, so here is the formula that I was talking about. I mean, it's really not too bad if you break it down. It just looks a little intimidating and would take a while to calculate. So I mean, really all we would need was number of data items. We'd need the sum of all the x values, the sum of all the y values. You'd need another column that was the sum of x squared. You'd need another column that was the sum of x times y. Okay, and so this is how we could calculate our b sub 1 and our b sub o. Remember, b sub o is the y-intercept, and b sub 1 is like our slope. Okay, so I mean, it is doable with small data sets, but you could see as data sets got pretty large how cumbersome that actual calculation could be. Now, again, technology will do it for you. If you have a TI calculator, just like with the variance and the standard deviation and all those cool things that we've had to do so far, the TI calculator, you go through and you can put in a set of data and figure out your line. But with smaller sets of data, it wouldn't be too bad to do. Your book goes through an example on the relationship between the age of cars and the asking price that someone would have. And so there's a table that shows cars' ages and asking price from a classified ad. And it took data from those two variables. You know, those are highly related. Anybody that buys cars knows the older your car gets, the least or the less it's worth, I guess, until it becomes a collectible. But even then, it may not be worth a lot, depending on the condition. But you can see this data was taken on this exact car, this Saturn SL1. And here's the age of the car and the asking price in the ad. And using the formula, they came up with a y-intercept of 12,519 and a slope of negative 1,391. And so we have price equals, that's y-intercept minus or plus the slope, which is negative, times the age, that's the independent variable. And so here's the line that they come up with. Notice the years are on the x-axis, that's where our age is. The price is on the y-axis. And here are the age and price. Each one of these points represents one of those classified ads. You can see here's the y-intercept here at whatever that 12,000 was, 12,000 something. And then you can see that in this table they have an error. This is the observed minus predicted, where the sum of the error equals 0. Okay, and so yeah, I mean, it's a lot of numbers, and this is really a small data set if you think about it. This isn't too big, and you can see how I guess how tedious the calculations would be. So using some type of software or some, a calculator, if it's a large data set, would definitely be needed. But don't let the formula scare you. It's really not that bad. Alright, so that was 5.7 and 5.8. 5.9, another really small section, interpreting the regression equation. Alright, so the equation that was come up with for that last example on cars was price equals, we had a y-intercept of 12,519.1, and then the slope was negative 1391.3, and then you had the age of the cars, which was our variable. It was our independent variable. So this changes the age of the car, and then the price changes. So if the age was 0, fresh off the lot, maybe we could talk them down to around $12,519. Good luck with that. But that's what, if you can actually let the age of the car equal 0, meaning it's just a brand new car, and that means that this would be the price. If this is, that would help us predict the price. So you see, once you have a regression line or a regression equation, you can use that equation to help you predict values. So if we wanted to know, after 5 years, an estimate of what the car would be worth, even if 5 is not in the data set as an X value, we could plug a 5 in right here and figure out about what we should ask. So the regression line actually allows us to predict values. Now it's not going to be exact, they're going to be approximations, but at least we'd have something to kind of go by to help predict 7, 8, 9 years down the road what the asking price of the car should be. Now the slope here, this slope in the problem, that's our b sub 1. The slope is always equal to the change in y for 1 unit change in x. Alright, the slope is always equal to the change in y for a 1 unit change in x. So, it's change in y over change in x, but for 1 unit. So what that means is, if you plugged in, say, x equals 4 and x equals 5, and you compared the two prices, the difference would be the slope.